Problem 4. Water is being heated in an electric kettle. The temperature, theta degrees Celsius, of the water t seconds after the kettle is switched on is modeled by the equation theta equals 120 minus 100 e to the negative lambda t. 0 is less than or equal to t is less than or equal to capital T. Part A. State the value of theta when t equals 0. Next, given that the temperature of the water in the kettle is 70 degrees Celsius when t equals 40, Part B says, find the exact value of lambda, giving your answer in the form the natural log of a divided by b, where a and b are both integers. Next, when little t equals capital T, the temperature of the water reaches 100 degrees Celsius and the kettle switches off. Part C says, calculate the value of capital T to the nearest whole number. Part A. State the value of theta when t equals 0. We know that theta equals 120 minus 100 e to the negative lambda t. When t equals 0, we put 0 in for t. So theta equals 120 minus 100 times the quantity e to the negative lambda times 0. That means that this quantity is 1, because anything raised to the 0 power is 1. Then we know that theta equals 120 minus 100. So theta equals 20 degrees Celsius. Part B. Find the exact value of lambda when the temperature is 70 degrees Celsius and t equals 40. We know that the temperature is 70 degrees and 40 seconds have passed. So we plug these into our equation to get 70 degrees equals 120 minus 100 times e raised to the negative 40 lambda. Now we begin to solve for lambda. First, subtract 120 from both sides. Next, divide both sides by negative 100. This is negative 50 divided by negative 100, which is 1/2. Take the natural log of both sides. Simplify. Remember that the natural log of e is 1. Now we divide both sides by negative 40 to get lambda. Don't stop here. It said that lambda needed to be in the form the natural log of a divided by b, where a and b are integers. We need to keep going. Remember that 1/2 can be written as 2 to the negative first. Now simplify. That's the same thing as negative 1 times the natural log of 2 divided by negative 40. So our final answer for lambda is the natural log of 2 divided by 40. Part C. Calculate the value of capital T to the nearest whole number. We know that the water temperature will reach 100 degrees Celsius. We also found the value of lambda in our previous problem. So we plug these things into our equation. So we have 100 equals 120 minus 100 e raised to the negative natural log of 2 divided by 40 times capital T. Now we solve for capital T. First we subtract 120 from both sides. Then we divide both sides by negative 100. Now take the natural log of both sides. Simplify. Divide both sides by negative natural log of 2 divided by 40 and evaluate. This is about 92.877. We want to round our answer to the nearest whole number, so that's 93. And T stands for time in seconds, so after 93 seconds, the kettle will switch off.